Hi everyone, welcome to this video, which will actually be part of a series of videos. This video will primarily be about GraphQL, what GraphQL is, why you might want to use it, how a GraphQL API looks like and works, and so on. But it will also be the first video of a series of videos where we will build an entire project which will use GraphQL. We'll build an event booking API and frontend application. So not just the GraphQL API, but also a frontend that uses this API. Now, as I mentioned, we'll work with GraphQL. We'll build that GraphQL API from scratch, and I will teach you everything you need to know about how to build such an API, how GraphQL works. We'll use MongoDB as a database, which we connect to the GraphQL API. So we'll get our data from there and store our data there. And once this entire backend and this entire API is finished, which will certainly take a couple of videos, once that is done, we will attach our frontend, and that will be a React.js single-page application. So I will add this to the API then. And for good measure, once all of that is finished, we'll throw some charts into the React application so that we have charts in there, that we can see how we can use a charting library in a React app and chart some of the data we can fetch from the API. Now, this series is probably a bit longer, will be a couple of videos, and I hope you stick around. I hope you like it as much as I do. I'm super excited to get started with that. One important note regarding the prerequisites: we will build the GraphQL API with Node.js, and I do expect basic Node.js knowledge for this series. So if you want to follow along smoothly, you should have that. You can take my Node.js The Complete Guide course, which I recently released. It's super comprehensive, teaches you everything you need to know about Node.js. Would be awesome to welcome you there. But in the end, of course, you just need to have that knowledge wherever you got it from. And the same for React and MongoDB. I got courses on these topics, and you find links with great discounts below the video description. If you want to get started and want to know everything you need for this series, these courses are great. But in the end, you will just need some, basic to advanced knowledge for Node and Mongo and React to follow along smoothly. But with that out of the way, let's dive into GraphQL. What is that, and why would we use it, and how does it actually work? Well, GraphQL is in the end a replacement or an alternative to a RESTful API. Now, I already got a series here on the channel where we build a REST API with Node.js. And I also show you how to build a Node REST API as well as a Node GraphQL API in my Node Complete Guide, by the way. Links to both can be found in the video description. So I assume you know what a REST API is. A REST API has a couple of endpoints, if you remember. And of course, a core idea is that it's independent from the clients that connect to it. So we use a REST API for single-page applications or for mobile apps. So basically for applications where we don't return the views that should be rendered on the screen in the browser, but where we just return the data and where we receive data. And we exchange data between the front end, which is separated from the backend, and the backend. Now, a REST API is a great solution for that, and a GraphQL API is an alternative to that offers more flexibility. Now, what does more flexibility mean? Let's have a look at the limitations of a RESTful API. A RESTful API typically works with endpoints like get requests sent to /post. You would typically fetch a post there, and you might return JSON data that looks something like that. Now, what if we only need the ID and title here, though? What if we don't want the content? What if we don't want the creator information? In a REST API, you always send back all the data, if you need it or not. You have an endpoint, get request to that path, and then you get a fixed set of data back as a response. That is how REST APIs work. Now, if you want to have less data, one solution would be that you simply create a different REST API endpoint, right? You could have /post_slim to which you can send GET requests, and there you also send back post data, but only the ID and title. And you got what you need, right? The problem with that approach is that you will end up having a lot of different endpoints as your project evolves. And whenever your front-end engineers, or if you're working on the entire project on your own, whenever you need a different kind of data, you need to add a new endpoint on the backend. On bigger projects, this can slow down the entire development process because teams constantly need to basically work on the back end, work on the front end, and go back and forth. And even if you're working alone on your project, you constantly have to add new endpoints to your backend. And therefore, your backend API might quickly get too big. And then there might be unused paths and not really that great. An alternative would be that you use query parameters. So on this get post route here, you could accept a query parameter, data equals slim, and you check that value of that query parameter. And based on that value, you return a subset of the data you would normally return. Well, it's certainly better than having multiple endpoints, but you still have a very complex API at some point. Because you need to handle all these different query parameter values, you still have this constant loop between the front end and the back end teams, because the front end team tells you we need to be able to fetch that and that data, and then you have to add a new query parameter that supports that. So your API still grows a lot, and it might not grow regarding the endpoints, but regarding the logic in each endpoint, when you have to parse your query parameters for different values and then execute different code based on the values. So that is still not great when you need more flexibility. By the way, you might be wondering, but what is the problem? We can't just fetch the redundant data and render only a subset in the front end. Well, you can do that, but the problem with that, of course, is that you're fetching a lot of redundant data, which hits the bandwidth of your customers and which also slows down your app. Because if you download more data and you need to parse more data in the front end, which means in the browser or on the mobile app, then this simply means more computation work on the front end. Not ideal. So the third solution is to use GraphQL, which does not ship either of the problems we had in solution 1 and 2. Instead, with GraphQL, we can build a backend which exposes endpoints, or one endpoint actually, as you will learn, which is very flexible regarding the query that gets set to it. We basically expose a query language to the frontend, we could say. And therefore, our frontend engineers can request data in all kinds of shapes, but we on the backend don't constantly have to edit the API, because we expose it in a very flexible format, and then front-end people get only what they need. And you will see how that looks like and works in a second. So this is the reasoning why we might want to use GraphQL. Now, with that, how exactly does GraphQL work? Well, when we have our client, which is the browser or a mobile app, and we have our server, which is where the GraphQL API runs, then the question is, how do we request data when using GraphQL, right? With a REST API, we would send a GET request to some route, or a POST request, or a PUT request. How does that work with GraphQL? With GraphQL, you always send a POST request even when you're getting data. That is super important and something that can be very hard to get initially when you come from the REST API world. But you always send a POST request to one single endpoint, /GraphQL typically, but you can name it whatever you want. So you have only one single endpoint, /GraphQL, with a POST request. And the reason for sending a POST request is that GraphQL basically exposes a query language to the frontend. Like you have query languages for SQL or for NoSQL databases, this is like a custom written query language, which you don't have to invent on your own. There is a GraphQL specification, which we will implement in the next videos. And therefore, the frontend can send commands to the backend with such a POST request to fetch the data that is, well, basically requested through the command. Just as you can send SQL commands to the SQL database to instruct it to return a certain slice of the data. We use a POST request because POST requests have request bodies, and we can enclose or encode our command, our query, into that body. That's the idea here. Hence, we always have POST requests, not because we always add content, but because we need to send that data in the POST body. We need to send that query expression in the POST body. Now, this query expression looks something like this. This is a typical GraphQL query. This is what we send as text, as a string, in the POST body to that GraphQL endpoint. And on the server, we then need to parse that. Now, thankfully, since there is a GraphQL specification which defines the keywords and how such a query should be structured, we don't have to write a parser on our own. there are parsers following that specification for all popular programming languages, Node, PHP, and so on. And we will use such a parser in this series here too for Node.js, since we'll use Node.js. Oh, one important note, by the way. A common misconception also is that GraphQL is there to help you query Facebook's knowledge graph, or that it only works with React, because Facebook invented GraphQL and they first of all introduced it with React. That is both not true. GraphQL is an alternative to REST APIs, and it works with any server-side language and with any front-end framework, or even with vanilla JavaScript. It's not restricted to Facebook or React or anything like that. That were just the first use cases, but not the limitations of GraphQL. So back to that query. In a typical GraphQL query, and we'll look at that in more details when we write some, we have an operation type. So here we send a query. An alternative would be sending a mutation. A query is when we want to get data. Later, we'll learn about mutations, where we can also change data on the server. We have the endpoint, and we define that when we define the API, something we will do together in this series. The endpoint we want to target with that query. And then the fields we want to request, so the data we want to get back. And this shows us the flexibility, because here we're, for example, saying, I want to have the name and age for the user. However, theoretically, we might also be able to get like the email address or the living address. So there are more fields available probably, but we only get these two fields here. And the endpoint is just the user object with all its fields. And then on the front end, by writing such a query, we can define which kind of data we want to get back. Operation types are queries, which are there to retrieve data. If you would want to translate it to the REST world, that would be your GET request. But important, it's still a POST request in GraphQL. Everything is sent as a POST request. But translated to the REST world, this would be your typical GET request. We got mutations, which is when we want to change data. Therefore, if we would want to translate this to the REST world, this would be the POST, PUT, PATCH, and delete methods. Again, only POST is used here in GraphQL, but this would be how you would have done it in a REST world. And we also have subscriptions. This is implemented via WebSockets, and this is for scenarios where we want to push updates from the server to the client. We need an established WebSocket connection for that. So that is GraphQL. If we have a look at it in a big picture, we have the client, browser, mobile app. We have our server with the GraphQL API running on it with that single endpoint. Then we have a couple of query, mutation, and subscription definitions on the server. This is how we define our API. We, as a developer, we write these definitions. We have some type definitions, because GraphQL is actually a typed language. It's not a programming language, but the query language we're essentially using here, which was defined and evolved by Facebook, uses types so that we are very clear about which type of data is returned for a given endpoint or is edited. And all of that works together. The types are used in all these other definitions, and we will write that all, no worries. And then in the end, we have so-called resolvers, and that is the logic that basically acts for the different endpoints and goes to the database, does something there, fetches something there. If we translate that back to our REST API world, then our definitions here would be the routes we define, the endpoints basically, and the resolvers would be our controllers. So in an MVC pattern, without the we in a REST API, but MC pattern, well, there we would have the routes, and then we would have the controllers, and the models, well, that is something we use in the same way in GraphQL and in REST APIs. We can simply define models, for example, when we're using Mongoose to interact with MongoDB. But we'll see all of that when we build that API. Okay, so that is a lot of knowledge. Let's have a look at a finished GraphQL API to get a feeling for how the code will look like before we then actually will start writing it step by step throughout this series. This is a project I prepared. This is roughly the API we will end up when we go through this series. I'm open for changes, and we might add some changes in between, but this is a full GraphQL API. Now, it's a normal Node Express application in the end. We start up the node or the Express server here. I connect to MongoDB. And the interesting part is this middleware, which we add here. In this middleware, we define one endpoint, GraphQL, to which requests can be sent. Important, I don't restrict this to post requests here. I accept all HTTP verbs, and I will show you why in a second. So this is the endpoint we expose by simply handling requests to this path with a normal Express middleware. And our Express middleware is this GraphQL HTTP function, which is coming from Express GraphQL. And that is simply such a GraphQL package helping us parse incoming GraphQL queries for Express. And such packages exist for all kinds of frameworks and all kinds of languages, not just for Node and Express. Now, there we define a schema, which are these definitions for queries, mutations, and so on. And then the root value is basically a combined version of all these resolvers for the endpoints. We'll have a look at it in a second. This option here, graphical true, is very interesting because this will give us a graphical user interface to play around with our API. Very interesting. And here I just define how thrown errors should be handled, but we will go through all that. We'll actually write it from scratch in this series. Now let's have a look at the schema and resolvers to get a feeling for that. I stored it here in the GraphQL folders. We got the schema.js file where I basically merge all my definitions together in one long string, which I pass to build schema, which is again coming from a third-party package that does some parsing too, and basically parses the schema I define as a string into JavaScript objects and so on that can all be then targeted with incoming GraphQL queries. And resolvers, well, there I just have an object combining parts or properties, methods of other objects, and we can find all the interesting stuff in these subfolders. Starting with the schemas, we'll have an event booking API, so we will have users and events for sure. And for example, here I define how an event should look like in the GraphQL world. And then here we have the different endpoints, different queries. We can send one to events, for example, pass some metadata, and then get back an array of events, and different mutations for creating, updating, booking, and canceling. And you don't need to understand that right now. We will write that from scratch. This is just how this generally looks. We have these definitions. Now, definitions alone don't do much. So for events, just as for users, we have resolvers, which kind of back our endpoints up. And if we have a create event method here in this mutation, without knowing more than that, we always need to have a create event resolver method here. And indeed, this is also named create event because I have such an endpoint in my schema. And here we define the logic that should be executed when a request has a query that wants to send a mutation that targets create event. And we'll send such requests together very soon. Then we execute this code, and here I have normal JavaScript code where I create a new event that is based on my event model, which I set up with Mongoose because I'll use Mongoose to interact with MongoDB. And then in the end here, we just saved it to the database and so on. So that is what we'll write from scratch in this series. Now, I mentioned that we have this nice graphical interface, and this allows us to see the other side, how we write queries without adding a frontend, which we'll do in the series, but it's nice to play around with the API without needing to write a full frontend. To see that, I'll just bring up my development server with npm start. There you'll not see much, but we can visit /GraphQL there. And this actually will load this graphical user interface, which I didn't program, but which is shipped as part of this Express GraphQL package when we enable GraphQL true. And this is, of course, only there for development, for debugging. We will not ship this in a production-ready app typically, but this is great to explore our GraphQL API as we write it, because this, of course, is connected to the GraphQL API we define with our schemas and with our resolver. And in there, we can write GraphQL queries. Now, you of course don't know how the query language works right now, and we'll dive into that deeply throughout the course. Generally, you have two types of queries. You have mutations for changing data, adding, deleting, updating, and you have a query for fetching data. You can write query here, and then curly braces, and then if you hit Control space, that's the nice thing, you get some auto-completion, where you see all the query endpoints you have in your application. For example, here, I got a login endpoint. Now that is a user-related endpoint, which we see in the user schema. There, under user queries, we have that login query. That is where this autocompletion is coming from, by the way. And then when logging in, we just need to pass in some extra data. This is also defined here, and the autocompletion knows all of that, which is great. And then we can just pass that data in here. For example, test.test.com is a user I created here, password tester. And then we again add curly braces, and then we can tell GraphQL which data we want to get back. Now here I can get back a token and a user ID because that is how my auth data, which I defined as a return type here, looks like. Auth data has a token and user ID. And in the resolver, I of course need to make sure that my respective resolver that belongs to this endpoint returns that data. That is my responsibility as a developer. But then, due to the typing here, I get this nice autocompletion in this tool, and here I can get the token, or I get token and user ID. Or if I had other fields, I could get other fields. And that is the flexibility I mean. On the back end, we are prepared to return all, but we actually only fetch what we request here. And tools like Express GraphQL help us parse these incoming requests on the server and take the data we prepare on the server and only pull out the single fields we did request in our query, so that the filtering is done on the server side and not on the client side. And here, if I run this, then, for example, I did log in successfully because these are valid credentials, and I did get my JWT token here. And we will write all that logic in this series. I hope this gave you at least an idea of what GraphQL is and why we might want to use it. It will obviously become clearer as you use it. And this is what we will do in this series. So I hope you stick with me and you are in again in the next video, where we will start developing this GraphQL API from scratch. Hopefully see you there. Bye.